decided I would actually try and do a QualQuest video today. So we are given, and this was I believe number 6 in our test today. So we have a sequence of numbers xn. We're not told what they are at all, but basically you have some list of numbers that just tends to go on to infinity. So this was a true or false question pretty much. If we are given that, this should be if the distance between any two consecutive points eventually goes to 0 as n goes to infinity. So basically, as long as the points keep getting infinitely closer or infinitesimally closer to each other, then true or false, does that mean that there is a certain x in which the sequence will converge to? That's what we have to investigate. So the answer to our first problem is it is false. And the easiest way to do it is to use a counterexample in this case. So basically we just want to find one example of a sequence where it does go to 0, but the sequence does not converge to a finite value. So this is the one I picked. Let's use the summation of 1 over n as n equals 1 to a certain index I, and that will be our value xi. So x1 would be 1, x2 would be, 1.5, x3 would be 1 5/6. Basically, so that way we can show that the distance between any two consecutive points is 1 over I plus 1, which obviously as I goes to infinity will go to 0. So that part is satisfied. However, we were hoping that our index xn would converge to some value, to some fixed finite value. However, this summation will diverge to infinity very, very slowly, on the same order as the natural log. But, in fact, it does go to infinity. So, the first case the answer was false. There was a second part to this question. Now, instead of our limit of our differences just going to 0, now we are told that the distance, or that the sum of the distances between our consecutive points is finite somehow. So therefore, the question arises, does there exist, a certain x, which is our fixed point for our limit? So it turns out for our second case that the answer is in fact true. And, we can kind of figure this out by, intuition. Since the sum of all these distances somehow has to be finite, then we would expect that somewhere our sequence eventually slows down to a certain point. So let's take a tail end of this sequence and try and work with that. So I'm going to say that for all epsilon greater than 0, basically I'm going to cap off the tail end of our sequence such that for all of our epsilon, for our certain one that we're looking for, there exists some number n such that the sum of all the distances, after n is less than our epsilon. And we know this to be true since our total sum has to be finite. So we have our tail end of our sequence here, and then what we can show is that the distance between our starting point and our supposed limit point, that is going to have to be bound basically by a large triangle inequality by the distance between each consecutive point. So we have from x1 to x2, from x2 to x3. So we can group up all of these sums together, and then from our capital N to infinity, we have all of these sums over here. And fortunately, since we have a finite number of sums right here, we know that this sum has to be finite. And then we already know this here, that for any epsilon, it does exist a certain number n. So we know that we have two finite parts. So then our distance between whatever our initial point is and our final point, we know that will have to be a finite difference between them. And therefore, we can easily say that since x doesn't go off to infinity, then it will stay put in a certain point. So therefore, this equation does turn out to be true. Alright, Big Mac Sam. Later.